Well friends, in this video we will learn how to compute correlation coefficient. So let us have some data in this R console so that we can see how to compute correlation coefficient and do regression in R. So we go on with this. We come up, we have already some press the back arrow command and get some data. So I have the data. This is the data for price of some commodities, and this is the amount of weight data related to weight. So these are the two data sets that we have. Now for computing correlation coefficient, the first thing we have to see whether the number of observations in the under the two variables are same, because for correlation coefficient it is important that the data is available in pairs. Now one simple way is definitely to count out that how many values are there under price, how many values are there under weights. But let us go a little bit stylish in typing the command length price. So these will give the number of observations under price. So spelling mistake, GTH length price, and so we get 11 number of observations. Similarly, we can just make it correct. We can length, and here we have WT and weight. So 11, 11. That means here we can perform the correlation coefficient between the two. Now, what we do is the correlation command. Correlation command for R is COR. COR is the correlation coefficient. We give the name of the variables like price. No need to give any quotes, and then write weight. This is the name of the two variables, and since there are different methods of correlation coefficient, we go with the method called Pearson. So this Pearson word should be in quotes. So this should be completely in small letters. Capital letters will not work. Now when I do this, I get the value of the correlation coefficient minus 0.6440303. So this is correlation using Pearson method. Now one thing interesting, even if we write don't write the method, let us see whether the correlation formula works or not. We don't write anything about the method and we press enter. You see I get the same value. That means the default method is called Pearson's correlation coefficient, which is popularly denoted as R for sample correlation coefficient, and rho for population correlation coefficient, that is for the Carl Pearson's method of correlation coefficient. Now we know that there is another method quite popular, and it is the Spearman's rank correlation coefficient. Now if we want to compute the correlation for the same data set using Spearman's rank correlation coefficient, then we go there. Here what we do is that in case of method, we delete Pearson and we write Spearman, and we press enter. So when we press enter, we get it as 0.5995565. The value differs with the previous value because the previous one was computed using Carl Pearson's method of correlation coefficient, and here we use the Spearman's rank correlation coefficient for computing the values, and hence the difference is there. Now, having done this, let us have a clear screen once again, and we are here. Now, often we get the value of correlation coefficient and we are unable to understand whether the correlation is a high correlation, whether positive or negative. That is understood by the sign. There is no confusion at all. But whether it is a high correlation, can we consider it as a high correlation? Maybe positive or negative, that sign will tell, but is it a high correlation? That means what we want is a test of significance for correlation coefficient, a significance test for correlation coefficient. Now we want to test this. So for that, what we do, very simple command. We go here, and then just I type in core.test. That's all. Core.test price and weight method is Pearson. That means it will test the significance of Spearman's correlation. Significance of Carl Pearson's correlation. We press enter and then we get this. So Pearson's product moment correlation, here is it does not calculate the value of the correlation coefficient, comes at the end. Yeah, it is there, 0.6440303, and these are the 95% confidence interval. You see the confidence interval is quite big. It's from minus 0.8 to minus 0.0. So it's quite big. This is the corresponding, because Carl Pearson's correlation coefficient, significance of correlation coefficient is tested through a t-test with n minus 1 degrees of freedom. So n minus 2 degrees of freedom, sorry. So there were 11 pairs where n represent number of pairs. So 11 pairs, so DF is 9. This is the test statistic value, and look at the p value, it's 0.03. And now since p value is less than 0.05, remember this point, very important. Since p value is less than 0.05, so we tell that the correlation coefficient is significant. If it is more than 0.05 p value, then the correlation coefficient is insignificant. Significant means it has a role to play. It has something to do so far as relationship between the variables are concerned. So this is where we are. So this is how we perform test of correlation coefficient to understand whether the correlation coefficient is significant or not. So this is the thing. Now let us see what is the command for Spearman's rank correlation coefficient. Same command, not much. For example, this, and then cor dot test, and then we press enter. Okay, Spearman's rank correlation coefficient. You see the data is appearing here. Let us have a control L and have the command once again. So yeah, so this is the test that has come, Spearman's rank correlation coefficient. This is the p value. You see here the p value is more than 0.05. That means when we go for the Spearman's correlation coefficient between price and weight, that correlation is insignificant. Actually, price and weight, these are numerical values, these are exact values, nothing ordinal type of data, it is not there. So actually rank correlation is not recommended for this, but even then we are just watching it for the for our knowledge to understand how the command runs. So here you can see excellent example where a particular data set is significant in Carl Pearson's correlation coefficient, but insignificant in Spearman's rank correlation coefficient. After all, Spearman's rank correlation coefficient has less information because this is a non-parametric correlation. It has less information in it because data is converted into ranks and then correlation is computed. Now when you convert the data into ranks, you sacrifice some information, and so Spearman's rank correlation coefficient is not sensitive, or it is less sensitive compared to Carl Pearson's correlation coefficient, and that's why the one that is significant there has become insignificant in this case. So now there is a warning message, cannot compute exact p values. So there is a warning message. So if you want to get rid of this warning, then what you do is that you write here same command, just to put a comma and write exact equal to f. That means exact equal to f means they are telling that I cannot compute exact p values. Here exact equal to f means I don't want the exact p value, give me an approximate p value. In that case the same thing will run but without warning. Okay, so let me clear the screen and show you the command once again. Okay, this is the exact equal to false. Here you see everything has come but not the warning, because you have told that exact p value I don't want. Whatever you can do, you to just give me an approximate value, I'll be happy with that. So that is how this is coming, that correlation test correlation. So we have learned in this part how to compute the two important types of correlation, like Carl Pearson's correlation and Spearman's rank correlation coefficient for two data sets available in pairs, and then we have also seen the corresponding correlation tests. Now let us go with regression. If you have any question, I think this is the right time to ask the question. तो दोस्तों कोई question है तो पूछ लो. Okay, then let us proceed to regression lines and curves. So first is simple regression model. For example, obviously price will be the dependent variable because I want to have the price and then see its relation with weight. So weight is the independent variable, price is the dependent variable. So I put the Carl here and write weight. So this is LM price, then Carl. This is Carl symbol. It is available with shift button at the extreme left side of your computer and below the escape button. You press shift and you press there, you will get this Carl. So this tells that there is a linear model involving price and weight. So you press enter. So you get this entire data set. So this entire bit of computation. It tells you the intercept. So this is the intercept and this is the coefficient. So this is a linear model. LM indicates linear model, and this is the intercept. This is the slope. So that is the curve that we get. So this is what we get. Now if we want to predict the price values, so if you want to get the predicted prices, so this is the name of the variable, predict price. So this I give a name of the variable, and then I use this command equal to 28.0618, then minus 0.7825, then star into, and then what is the variable that is representing weight, so WT. So these will actually calculate the predicted values of price and store it under pre-price. So PRE, this is, sorry, not capital, PRE, PR price. So you want to see this together, I want to see this. So these are the predicted values of the prices. So this is how we see the predicted values of the prices. Now suppose you want to see the residual. Residual, you know, it's the predicted value minus actual. So you want to see the residual. What you do is that you go to, I am giving a name. You may write the complete word also residual, but I am giving a name resi that will compute the residual. So predicted price. So PRE underscore price minus price minus price. So this is the actual price. So this will give me the residual. So I get the residual. Residual is stored under the variable RESI, resi. So this is stored here. But now what I want is that I want to see the entire data set together. That I want to see the value of X. That means weight. I want to see the value of price. Okay, I want to see the value of the predicted price, and then I also want to see the residual in tabular form as we generally do. Here they are showing it separately. I am not enjoying. So what I do is that I write data, and then I write data frame. Data, and then we write data frame. So it comes as a data frame. First we write weight, then we write comma, then we write price, then I write price predicted PRE. Okay, I should remember not PRE, it should be PR, so that we have the same name. So weight is there, price is there, and this is predicted values of price is there, and then we have last resi. So this is the residual. So these will convert the entire data values that we have separate under variables into one data frame and store it in a variable called data. Here I have given the name data, you can give some other name. So we press enter. So I think price predicted, it has unable to find out because my predicted price variable name was PREPR, not its price PR. So what I do is that I go back and then I write PREPR, and then I get residual. So once I get this, so my data frame is now stored under data. So I control the clear the screen, and now I write data. So this shows me the entire data frame. So this is the weight, this is the price of the commodities, which is the dependent variable. This is the predicted value. So 2 is predicted to be 6, 3 is predicted to be 7, and here I get the residuals of this. So this makes my analysis quite complex. Okay. Now let us go and see some more aspects of this linear model. What we do is that I want to compute, or I want to store the result of linear model, some variable name. It's quite simple. I write linear, so this is the name of a variable where I will store the result. So I write LM price and then weight. So I write a linear model equal to LM price and weight. So I press enter. So these results get stored. I am not disturbed during my analysis because of the command linear model. As you see, have seen earlier that whenever I have typed, for example, if I go on and type here, only linear model. Then after I do this typing, so many things comes below that. Okay, so these if I want to avoid, then I will write this and press enter. So under linear model, this computation is done and press enter linear. Now I may want to see the summary of this. So some stage I may interested in summary. So I will write summary and then I give the name linear. Linear and press enter. So it gives me the complete summary. Okay, it gives the ANOVA table also. It tells me that weight is a significant predictor. Okay, and then it gives the residual. So if I decrease the view size, data editor, sorry, not data editor, if I decrease the preference size to, instead of 20, if I make 16, then I can get a better view. Okay, now I think everything. So you see the F statistic of ANOVA is this, which is less than 0.05. That means the regression is significant. Regression is significant. ANOVA table I am getting. ANOVA table is not in the tabular form, but it is in text form. R square value, adjusted R square value, multiple R square is 0.41. That means the independent variable explains 41% of variation in the dependent variable. So that is what we can tell from here. And p value of ANOVA is less than 0.05, indicating regression is significant. And in the regression equation, both intercept and slope are significant. So we are happy with these results that we have got here. So any doubt? So now let us, once we have drawn this graph, once we have done the calculations, we are in a position and we want to find out the plot. We are happy to see the plot. So for plot, what we do is that we write this and then we first basic plot, we get the basic plot and then we have price. So as soon as I type this, you will find that the graphics window is active now and it has been able to draw the graph. Now you are, if you want to have these points colored, so you may use this command, like you may have ECH equal to 16, fill equal to red. Okay, so there are some commands here, some errors there. Let us correct this error. As you know, in the previous class we have seen about this, how to make the correction in case of plotting these things. Instead of fill, it will be color. Now it will work. Have a look at the graph. Yeah, you see now the points are there. It's quite visible. And you see from the graph, you understand there is a decreasing trend. As weight increases, there is a trend of the values to come down. So the price decreases as weight increases. Means heavier things are more priced. Less priced. The finer things are very lightweight and actually are heavily priced. Anyway, so we come back to this graph. Now I want to add this line, that fitted line. So what we do is that we put AB line, and then if you remember, the name of the line was linear, and that is why then LTY equal to 3. That means it is the width of the line. LTY equal to 2, it will be a thinner line. LTY equal to 1, it will be a normal line, a very thin line. And then we have a different color because we have already given color to the points as red. So give us a color blue here. So we get a blue line fitted within the red line. So we press enter, no error is there, that means it is working. And if we want to see it, we can go here and we find that LTY equal to 3. So it's a dotted line. So I want to make it a little bit thick in size. So LTY, that is actually different types of lines. So this is line type. Line type 3 means it's a dotted line. So LWD, that is the width line. Sorry, earlier I had made a mistake. LTY is line type. So that is a dotted line. LWD, that is the width of the line. I will get a very thick line. As you can see, thick dotted line we have got. So this is the fitted equation. These are the points. So thank you guys for watching this video. Hope you enjoyed it. Thank you.